The 2000s marked an era of exponential growth in AI, deeply enriching technology's role in everyday life. Central to this decade's achievements was the evolution of autonomous driving, significantly propelled by DARPA and its grand challenges. These competitions weren't just races, they were catalysts for innovation, pushing the boundaries of what was possible in computer vision and reinforcement learning. The latter part of the decade saw industry giants, including Google and numerous car manufacturers, making substantial strides in developing autonomous vehicles, indicating a shift towards the technology's commercial potential. Equally transformative was the emergence of the Internet as a vast data reservoir, heralding the beginning of the digital age in 2002. The creation and utilization of extensive datasets through web scrapers and crawlers became a cornerstone for AI, fueling advancements in fields like predictive analytics and user behavior analytics. This era was characterized by a concentrated effort on data manipulation, sourcing, storing, transferring, and analyzing, setting the stage for sophisticated statistical models that leveraged this information for a broad spectrum of applications. Another significant development was the ascent of deep learning as the leading machine learning technique, supported by substantial hardware advancements and the refinement of neural network frameworks like Torch. Long short-term memory models became the benchmark in speech recognition and various NLP tasks, while CNNs, or convolutional neural networks, advanced the frontier in computer vision, aided significantly by NVIDIA's efficient GPU architectures. This period also saw the refinement of recommendation technologies, which transformed e-commerce and media consumption. By analyzing vast amounts of data, these systems personalized content delivery to user preferences, revolutionizing the way products and services were marketed and consumed. The DARPA Urban Challenge further spotlighted autonomous driving, emphasizing the technology's capability to navigate complex urban environments. This challenge not only tested the technological prowess of autonomous vehicles, but also showcased their potential to transform urban mobility. Additionally, the 2000s introduced a growing interest in enactivism in the context of AI. This philosophical framework, emphasizing the role of environmental interaction and sensory motor experience in cognition, began influencing AI development. It advocated for AI systems that adapt and learn by engaging with their surroundings, providing a more dynamic and interactive model of intelligence that contrasted with traditional computational approaches. Together, these developments underscored the 2000s as a period of significant innovation in AI, laying a solid foundation for the digital intelligence that would come to shape the future of technology and human interaction. The 2010s heralded a new era of deep learning, driving unprecedented advancements across various domains of artificial intelligence. This decade was marked by the specialization of neural network architectures, each tailored for distinct data types, leading to groundbreaking achievements in several key areas. The decade witnessed the rise of voice-activated assistants like Siri, Cortana, and Google Now, which became integral to consumer electronics. These AI-driven helpers transformed user interaction with devices, making voice commands a natural mode of communication with technology. Remarkable milestones in AI were achieved through AlphaGo, DeepStack, and IBM's Watson. AlphaGo's victory over a world champion in the complex board game Go was a significant demonstration of AI's strategic depth and learning capabilities. Meanwhile, Watson's triumph on the quiz show Jeopardy showcased AI's potential in understanding natural language and retrieving knowledge. To combat the brain drain in Europe and retain talent in the field of AI, the Ellis Initiative was launched, drawing inspiration from institutions like CERN. This aimed to create a network of excellence in AI research across Europe, fostering collaboration and innovation. The decade also saw AI themes prominently featured in popular culture, with films like Ex Machina exploring the ethical and philosophical questions surrounding artificial intelligence and robotics. The decade was further characterized by significant technical advancements. Convolutional neural networks, particularly through models like AlexNet, revolutionized computer vision once again, setting new benchmarks for image recognition accuracy. Tools like AlphaFold made significant strides in biomedicine, particularly in understanding protein structures, which is crucial for drug discovery and toxicology. The development of architectures such as BERT and GPT-1, which utilized attention mechanisms and transformers, revolutionized natural language processing, making machine understanding and generation of human language more sophisticated. AI techniques improved image quality through denoising, super resolution, and colorization, showcasing the potential of generative models in creating and enhancing visual content. The introduction of the transformer architecture by DeepMind was a core moment, simplifying the training of neural networks and expanding the use of LLMs across various fields. The emergence of entities like Google Brain, DeepMind, and OpenAI underscored the commercial potential of AI, with many transitioning to for-profit models. Generative AI captured public imagination through its ability to create new, original content, symbolized by tools like Deep Dream and practical applications of GANs, or generative adversarial networks. The availability of these technologies broadened through cloud computing, making powerful AI tools accessible and showcasing their practical applications. As the 2010s concluded, the stage was set for AI to expand its influence, demonstrating its capability to address complex challenges and enhance human creativity, with the foundational work for future explorations firmly in place. The 2020s have been christened the AI era, a period distinguished by rapid advancements in artificial intelligence, fundamentally altering the technological landscape and its integration into society. This decade's hallmark is the profound impact of large language models, such as OpenAI's GPT-4, Anthropic's Claude 3, and Google's Gemini models, which have all shown the need to redefine the boundaries of language processing and generation capabilities. GPT-3 in particular, with its unprecedented scale, was one of the first models to adequately showcase the potential of AI to perform a broad spectrum of language tasks, from writing poetry to generating computer code, with a proficiency that closely mirrors human output. In parallel, the realms of biomedicine and mathematics have witnessed groundbreaking achievements with AlphaFold 2 and AlphaGeometry, some of Google's models in medicine and math that brought home medals against humans and other AIs. This milestone not only signifies a monumental step forward in drug discovery and our understanding of biological processes, but also underscores the versatile applicability of AI across different scientific domains. However, the rise of these technological marvels has not been without controversy. The introduction of ChatGPT and GitHub Copilot, alongside the deployment of AI in generating art and content, has sparked intense debates around copyright infringement, ethics, and the responsibilities of AI developers and users. Legal challenges, including class action lawsuits against major tech companies, highlight the growing need for a regulatory framework that addresses the copyright and ethical dilemmas posed by AI technologies. Moreover, the adoption and integration of AI into everyday life and various sectors have accelerated discussions on the governance of AI. Initiatives like the AI Safety Summit and the Executive Order on the Safe, Secure, and Trustworthy Development and Use of Artificial Intelligence reflect a collective effort to mitigate the risks associated with AI. These discussions are further amplified by the call for a halt to the development of uncontrollable AI systems by industry leaders, signaling a critical juncture in the evolution of AI where its potential benefits are weighed against the existential risks it poses. GPT-4, the latest iteration in the GPT series from OpenAI, exemplifies the apex of multimodal model development in the 2020s, integrating advanced language understanding with an ability to process, interpret, and generate responses based on a wide range of inputs, including text, images, and more. This model has significantly broadened the scope of AI capabilities, enabling nuanced interactions across various modalities of data. By leveraging vast datasets and employing sophisticated training methodologies such as reinforcement learning from human feedback, or RLHF, GPT-4 not only surpasses its predecessors in generating coherent and contextually relevant textual outputs, but also in understanding and generating content across different data types. This advancement marks a significant milestone in AI's journey towards more generalized intelligence, offering unprecedented versatility in applications ranging from creative content generation to complex problem-solving across domains. The evolution of GPT-4 reflects a broader trend in AI research towards creating systems that more closely mimic human cognitive abilities to interpret and generate information across a multitude of sensory inputs, heralding a future where AI can seamlessly integrate into a wider array of human activities and industries. Adding to this era's innovations, the development of Sora, a generative model capable of producing high-fidelity videos, represents a significant leap in AI's capability to simulate the physical and digital worlds. By turning visual data into space-time patches, Sora enhances video generation's flexibility and quality, demonstrating AI's growing proficiency in creating content that spans various durations, resolutions, and aspect ratios. This advancement highlights the AI era's commitment to pushing the boundaries of technology, further solidifying AI's role in transforming creative, educational, and scientific endeavors. As the 2020s progress, AI continues to redefine the frontiers of technology, with advancements in multimodal AI, generative models, and ethical AI development shaping the trajectory of this era. The widespread adoption of AI across industries, coupled with societal and ethical implications of these technologies, underscores the transformative impact of the AI era, heralding a future where AI is integral to solving complex challenges and enhancing human creativity and innovation.